So you are supposed to calculate the distance between the tangent and the chord. What did you get? 4 centimeter. So the radius of the circle was 5 centimeter. The chord is 6 centimeter drawn parallel to the tangent to the circle. A circle is radius. A chord of 6 centimeter is drawn parallel to a tangent to the circle. Calculate. So you are supposed to draw that chord. This is the chord is 6 centimeter. Then a tangent is drawn here, which is parallel to the chord. And you are supposed to get the distance between the tangent and the chord. So this distance here. Now we have this is 5. So we have this is you can say this is x, and we can be able to find the value of. So if this is x, what we normally say is that a chord, a line joined from the center bisect the chord. So this means that is 3 and that is 3. So we can be able to find this is the radius, so we can be able to find x. So it is 25 minus 9, you get what? 16. For you to get x, it is equals to the square root of 5 squared minus 3 squared, correct? That is the Pythagoras theorem. So that gives you the square root of 25 minus 9 is equals to the square root of 16 is equals to 4. So we can say x is 4, sir, which you got. But where you went wrong is you did not answer the question. Calculate the distance between the tangent and the chord. So what is the distance between the tangent and the chord? 9. So the answer should have been 9. Distance from the chord, distance, they can say distance between, use this correct, distance between the chord and the tangent is equals to 4 plus 5, which will give you 9 centimeter. So that is why I said when you're answering questions, ensure that you have you are keen, okay? Because if you give 4, you just get part of the marks. If it is in an exam, then you don't get full mark, okay? Because you have not answered the question. However, it is good that you are able to get 4 and you only miss in that small bit. We go to the next question. What did you get here? You are supposed to show that BD is equals to 2 centimeter. Calculate the length CD. Did you calculate CD? Yeah? 22 centimeter. What about the CD? Arc length CHG. CHG is this one. this is the CHG. Did you calculate the arc length there? 13. So you have CHG is equals to 13 centimeter. Then you are supposed to find arc length and DEF. Did you find DEF? 7 centimeter. All right. Hence the total length is equals to 40. So those are the answers that you got. Right. Now, the diagram represents two pulleys. So you have this, the information given. Now, you are given this is 20 and this is 12. You can use angle 60 because this angle here is 90. You can use 20 and angle 60 to be able to get this distance here, as well as this distance, which is actually the length of CD. So we need that you can try whether you got the correct value. So you can say we need the opposite. So we have the hypotenuse, and so we can say, we say tan 60 is equals to, tan 60 is equals to opposite, which is our CD. You divide by the hypotenuse, which is 20, and this implies that CD is equals to 20 multiplied by tan 60. Is that what you got? That gave you 22. You get 34. So meaning that this side is 34. You have confirmed with the calculator. Therefore, and we know that this side, which we have calculated, is parallel and equal to CD. So it means that CD is also for 34 centimeter. Are we together? We are supposed to find the CHG is actually a sector, correct? And the formula for finding a sector, what is the formula for finding the length of an arc? This is a major arc. Arc is equals to, that is CHG is theta. That will give us the area. We are looking for the length. It is 2 pi r or pi d. Why are we saying that it is 2 pi r? Because CHG is part of the circumference. Is that true? So that when you say pi r squared, that is, we do that when we are looking for the area of the sector. But when you are getting the length of the arc, we use 2 pi r because it is a fraction of the circumference. So this angle here is also 60, meaning the angle that will be left on the other side is this angle here. We are given it is 60, isn't it? It is the same as this angle, correct? So the two angles add up to 120. So the angle that we need to use is this angle. Okay? So what is the size of that angle? Huh? Not 60. It is 360 minus 120. That will give you 240. Is it true? Divide by 360. You multiply by 2. Multiply by 22 over 7. You multiply by the radius is 12. So using your calculator there, can you compute this? That you cancel with that. Divide by 12, that is 2. Divide by 12, that is 3. Divide that by 3, here you get 4. So can you multiply 2 times 2 times pi times 4? You get what? Or 16, it is the same as 16 multiplied by pi. 50.29. Sawa. So that is so this means that this is 50.29. The other one that we need to calculate is this arc. That is DEF. Now, if we have that is so if for us to be able to calculate that, we know this angle here is 90, correct? So if that angle is 90, then and this angle is 60, this angle here is 90, it means this angle here is 30. This small angle, can you see it? If that angle is this angle is 30, it means the whole of this angle is 120, and this other one is 120. Are we together? So this is the angle that we need to calculate the length. What is this? What is the angle at B? 120. So that all of them add up to 360. That is 360 minus 240 is 120. So just like we have done here, we say DEF arc is equals to 120 divided by 360. These are degrees. Multiply by 2, multiply by 22 over 7, multiply by r. We need the radius of this circle, and for us to get the radius of that circle, since we have the angle 60, and we can be able to use that angle and say the cosine of 60. We can say cosine of we can use either we can use opposite side angle 30, or we use 60 and adjacent. So we say cosine of 60 degrees is equals to adjacent will be we can call it x. So it is x divided by the hypotenuse, which is 20. So it means x is equals to 20 the cosine of x. That will give the cosine of 60. That gives you to what? I believe that will give you 10. So that gives you 20 centimeter. If this small, okay, the diagram is not proportional, it means the radius of this small circle is 2 centimeter. Is it correct? You got that. So you multiply by 2. So this will give you 1, 3. So can you multiply 22 times no, the 22 times 4 divide by 21. 22 times 4 will give you 88. Is that correct? 88 divided by 21. 4.190. We can leave it to 2 decimal places. Now, so we can say now this side here is this length is 4.19. So the last part of this is hence find the total length. CD is equals to GF. Is that correct? So that is 34. So to get the total distance, then it means you add 34 plus 50.29 plus 34 plus 4.19. 4.19. Can you add up that? Can you sum up that? Okay. One 23.09 centimeter. So that is the we can call it the perimeter of the belt. That's correct. So that is how you are supposed to approach that. I think you got some of them, but where you had problem is getting the C. You are not able to get this one correctly. CGH. Maybe you use the wrong angle. Yeah. What angle did you use to get the length of arc CG? Or you use pi r squared? Oh, that is where you are. You use pi r squared when you are calculating the area of a sector, but when you are calculating the area of the arc, you use 2 pi r, because an arc is a fraction of the circumference. Get that? A sector, area of a sector, is a fraction of the area of the circle. So that's the difference between the length of an arc and the area of a sector. So I hope that one is clear. Do you have any question? Fine. Good. Okay. Now we start with what we had planned to do today. Today I told you we are going to look at the angle properties of a circle. So as you can see on my board, I have a circle with AB is a diagonal. This is you can call it diagonal. From the diagonal, we have so the diagonal divide the circle into 2 equal parts. We call them semicircle. Are we together? If you draw an angle subtended by a diameter, it is equals to 90 degrees. So that is a property that you need to know. So at any point, even if I take another one here, I bring sorry, let me correct that. Even if I draw some, let me remove this. So what I'm saying, even if I draw another one here, it will still be 90. Are we together? So triangle, so the angle P, that one, Q, they are subtended by a diameter at the circumference of the circle. They are equal to 90. The same case on the other side, angle R here, angle S, they are equal to 90. So that is a property that you should always remember. Are we together? You can put it down, then we move to the next property. Let me remove. I think that's okay. So you can put that down and put this statement. Angle made by a diameter of a circle at the circumference is 90 degrees. That is very important. You are through? Very good. So we go to the next property. The next property, as you can see on my board, I have a circle and I have a chord. This is a chord now. We have dealt with a diameter, but now this is a chord. A chord is made up of 2 points that lie on the circumference of the circle, but it doesn't pass through the center. So this property says these angles are called PQ. This is called a segment. We mentioned that when we started, isn't it? And this is actually we call it major segment, and this is minor segment. Now, a chord, you can see we have I have subtended angles here. We can call this A, this is B, and C from chord PQ. So this means that this property says angles subtended by the same chord in the same segment are equal. So this implies that angle A is equals to angle B is equals to angle C. That is in the major segment. In the minor segment, we can call this is D, and this is angle E. It also implies that since angle E and D are subtended in the opposite or in the alternative segment, then it means D is equals to angle E. Are we together? So this property says angles subtended by the same chord in the same segment are equal. And that is very important. You keep that in mind. So can you put that down? Is it if it is clear? Yeah. Yeah, you are through? Very good. So I hope that one is clear too. We go to the next one. Angle properties of a circle. Now, in our diagram here, we have, yes. Which one? Okay, finish that one. All right. So the next thing that we are going to look at is this. What we have, I have a diagram here showing 4 chords. That is called AB. We have BC, CD, and AD. So when we have 4 chords, these 4 chords joined together, we refer to this as a cyclic quadrilateral. A quadrilateral is a 4-sided figure. You know that, eh? Like a rectangle is a quadrilateral, a circle is a quadrilateral, such. So when you have a 4-sided figure with its vertices touching the circumference of the circle, we refer to this as cyclic quadrilateral. Cyclic quadrilateral. So that is important. Now, the property that we have here is that when we have a cyclic quadrilateral, The opposite angles of the cyclic quadrilateral are supplementary. Supplementary angles add up to 180. So that is, we have A and plus C add up to 180. B is opposite angle is D, it add up to 180. So that is a property, and it is the one that I have put here. So we say opposite angles of a cyclic quadrilateral are supplementary. Supplementary, I have said, it means supplementary angles add up to 80. Two angles adding up to 180. So angle A and C are supplementary. So A plus C is equals to 180. B plus D is equals to 180. Is it clear? So that's another property that we use that help us to solve angles when a circle is involved. The other one is we have angle E here. This angle is formed as a result of extending chord CD where it joins with the chord BC. So that is where the angle is formed. This angle here. Now that angle is called exterior angle, and this angle, exterior angle, is normally equal or is equals to the opposite side, the opposite angle in the cyclic quadrilateral. So this means that A is always equals to A. Is it clear? Exterior angle is equal to the interior angle the interior opposite angle, which is A. A and A are equal. So that's another property that we also use when we are solving angles involved in a circle. So you can put that down if it is clear. Then we move to the next. Yes, ask. Chord CD. Then if it was not extended, then we would not have an angle. You see, like if I delete it like this, and then we say this is our C, then you see an angle is formed when we have when we have a straight line, we have an angle of 180. Is that true? So when we have any other line lying on that line, then that is when the angle is formed. So if we don't extend that chord, then it means no angle will be formed. So we will not have exterior angle. Is that clear? All right. So go ahead and draw the diagram and put this down. Yes, you are true. So those are, we look at another property, and here we have angles in alternate segment, right? So here what we have on the board, we have the first circle here, and I said a chord divides the circle into two segments. We have the major segment and the minor segment. Now, when we draw a tangent like this one, that touches the chord, what is formed is an angle. This angle X. Okay. Now, when we now subtend, we subtend an angle using that chord. We look at this one. This is a segment. Its alternative segment is this one, which is actually the major segment. But now, in other words, it is the alternate segment to the small one. So this property says the angle formed by the chord and the tangent is equals to the angle subtended by that chord subtended by that chord in the alternate segment. This is the alternate segment to this one. So the angle formed by the tangent and the chord is equals to the angle formed by the chord at the circumference in the alternate segment. Are we together? The second question we have, actually we can, let me label these chords. You can say this is A and that is B. Let's say that is Q. We can say this is, the second one is opposite of the first one. We have PQ and we have M. So what this means is that now this is the alternate segment to this one. And as you can see, our chord PQ and our tangent forms an angle which I have labeled Y. Is that correct? So when the angle subtended by this chord in the alternate segment is B, and because we have said that the angle subtended by a chord and the tangent formed by the tangent and the chord is equals to the angle formed by the chord in the alternate segment, then what this means that the angle Y is equals to angle B. So Y and B are angles in alternate segment. They are equal. So that is another property that we have. So put down. So those are the properties that I wanted us to have a look at. Now you can put this down. Then we look at the application of now these properties that we have gone through. Sasa, yeah, put that down. No. So those properties are very important. So let's have a look at an example. Before we go to that example, it's something that I wanted us to look at. We want to, we can be able to, I want us to look at why we are saying that angles subtended by the same chord are equal. So can you draw a circle like the one that I have here? Do that. Then you make a chord there. That chord you can label it PQ. Have you done that? Okay, draw another line here. me use that. Draw another line there. And another line there. So that's we have subtended an angle. We can call it A. We have subtended an angle using the code PQ, and we have that. Are you there? Can you hear me? Can you hear me? Yes, can you hear me? Okay, now use a ruler. Okay. Use a ruler and draw a tangent like this one. Yeah, draw a tangent like the one I have drawn there. Are you through? Then you can see the angle that I've extended with a black color line. That passes through the center. There is another subtended angle which I have labeled X. So this one passes through the center of the circle. So PR is diameter, okay? PR is diameter. So can you draw that diameter? Have you done that? You have done that, eh? Okay, now this ratio, this theorem says, so we have said that when we have a tangent and a chord, the angle they form is equals to the angle that is at the circumference of the alternate segment, correct? All right? Can you get me? Halo, unanisikia? Halo, can you hear me? Aya. Now I want us to look at this theory. Why we are saying that A is equals to angle X because they are subtended by the same chord. Is that correct? Now, the reason why we say that is because we have said P is equals to A. The angle formed by the chord and the tangent is equals to the angle subtended in the opposite segment, alternate segment. That's correct? But we have said that PR is the diameter. So this means that angle RP, we can say angle, let's say M, RPM is equals to 90 degrees. That's correct? Let's call this angle is Y. So this means that P plus Y is equals to 90, and P is equals to A. All right. That means that if P plus Y is equals to 90 and P is equals to Y, if P is equals to A, so it means Y is equals to P is equals to A. Then we say that since this angle is 90, that angle is 90, and we have our, just a minute, this angle here is 90. That means that X plus Y is equals to 90 because they form the triangle PQR. Can we say that? Now, from this statement, we have P. Let me use a different color. Just a minute. We have this statement that says P plus Y is equals to 90, and we have X plus Y is equals to 90. See this, we can conclude that P is equals to X. Can we conclude? Yes, P is equals to X. And initially we had said P is also equals to A. So both those two are the same. And therefore, using this triangle PRQ, we have shown that the angles subtended by the chord, by the same chord, are equal. So this triangle in black has helped us to prove that the two angles X and A, implying that X is equal, A is equals to, so that is the alternate segment theory. We can be able to do that. So we had covered that. So what you do, here we have an example which I've written here. You put it down, then we can have a break of 15 minutes. Then we come and look at it. Yes. You have a question? Yes. Hello. Yes. Can you? in the same topic. Actually, after we are through with this, if we have time, we'll start it today. After we do several examples of the application of what we have run so far. Yeah, so if we do them maybe 2 or 3 examples, we can start on circumscribe, inscribe, and ascribe. Yeah.